everyone, today is fun maths. 2 plus 2 equals to 5. Oh, what's this again? Today we are talking about inertia. What is inertia? This is a question on the Kirchhoff law now. Let's start analyzing it. Now, remember the first thing we do. The first thing is to know the direction of current. Now, we have been given the direction here. Those are the direction given to us in this question. Then we can say that, okay, at this junction now, this one that is moving, it's moving like this. It's entering this junction, and this one also is entering this junction while this one is leaving the junction. Then I can now say, okay, this is my I1 and this is my I2. You can use I1, I2 and I3. Anyone you will feel like using, you can use anyone. Then since I have known the direction of my current, the next thing is to know the polarity of the resistor. All right, current is flowing like this. Here will be the positive terminal of the resistor. This is negative terminal of the resistor. Current is flowing downward like this. This is positive, this is negative. Remember, current is going like this, which means current is moving like this, which means current is moving like this in this direction like this. So this should be my positive, this should be my negatives, because current move like this. This is a junction, so before you reach your junction, so current move like this, it move like this, then you can see that it enters that junction. And then the last one there like this, which current flows here? The current that flows here is still this, because that is the same wire that connects this one. So you say, okay, current move like this and it enters the junction and it comes out like this. So this place will be positive, this place will be negative. That is the other part. Once you know how to assign your polarity to it, then it is easy to analyze, and that is that. Now, since we have done the second one, the next one is to use the KJL, which is our junction law. So we can take the top one. I can decide to take the bottom one. I'm going to take both and show you that they are going to be the same. Now, here the junction law says that the one entering must be equal to the one going out. I is entering, we have I1 also is entering plus I1, and I2 is leaving, equals to I2. So that is that for this. And if I should take this place, remember this is still your I, because this current is still your current. It's still your I current that is flowing here. Here is your I2 that is still flowing along this wire. And here is your I1 that is still flowing along this wire. So this one will be your I, this one will be your I1, and here that is moving downward, this one will be your I2. And if you are taking this junction into consideration, I2 is the only one that is entering, and I1 is coming out of it, and I2 also is coming out from it. So that is how you can see the two is related. So that's how you resolve that junction law. Now let's move to the last one. The last one is KVL, Kirchhoff voltage law, which means we are talking about the loop. Now, if you are not talking about the loop, now we have 3 loops generally in this diagram, but we are considering only just 2 loops, the one here and the one here. Say this is loop A and this is loop B. Now, in loop A, I may decide to go clockwisely. Now, if I want to go clockwisely in loop A now, let's analyze the voltage inside loop A. If I'm starting from this guy here, so I move from positive to negative, that is 6. But remember, it is V equals to IR. So what current flow this guy? It is still your I that flows this guy, that flows through this guy. So I current flow through this guy. Inside this one, I current flows through it also. Inside this one, it is I2 that flows through it. Hope you understand. It is I2 that flows inside this guy here. So here, you are moving from positive to negative. That is minus 6 times I is 6I. We get that. That is V equals to IR. So this is our R, this is our I. So moving upward, I meet voltage on my way. So voltage is from negative to positive, and that means that is plus 10 voltage. Then I'm not going to put that the unit. That's plus 10. Then moving upward again from positive to negative, that is negative. Now 2 times the current that flows through here is I also, that is 2I. Hope you are getting this. I'm moving through the wire again. We reach another voltage, which is 6 volts. So it moves from positive to negative, that is minus 6. Coming down also, we move from positive to negative, that's minus, and this is 1 ohms. That's 1 times I2, because it's I2 that flows this. That's 1 times I2, that's we have I2 like that, and we just end up from where we start. That's all, everything equals to 0. Then you solve. This will add up to this because they are both having I. So minus 6 minus 6, that we have minus 8I. So we have 10 minus 6, that's plus 4, minus I2 equals to 0. Pushing all the I to one side, I can say we have 4 equals to 8I plus I2. That is that for the first loop, for loop A. Now let's check for loop B. For loop B now, I can decide to go anti-clockwise. It's any way you wish to go. You can go clockwise, you can go anti-clockwise. Just know that the direction you are in which you are going is still the direction you are moving. Now I'm going to start from here. Let me start from here. So I'm going anti-clockwise, which means I'm going like this. So I'm moving from positive to negative. That is negative 4. But which current flows through here? Remember, it is I1 that flows through here. I1 flows through here, so we know that it is 4I1. Moving upward, I meet negative to positive terminal voltage, so that is plus 9. Moving like this, moving like this, moving like this, I encounter another voltage which is from positive to negative, that's minus 6. And the lastly I meet another resistance which is from positive to negative, which is minus. Current that flows through this I is I2, so 1 times I2 is I2, which is equals to 0. That's all about the loop B. Now let's add up our answers. So we have 9 minus 6, we have 3, minus 4I1 minus I2 giving you 0. Pushing all this to the other side, I have 3 equals to 4I1 minus plus I2. Now you have different equations. You are done about that again. Now to now solve simultaneously. If you have a calculator, you can punch it in calculator, but if you don't have a calculator and you have to solve this, what you do is that check your first loop equation. You see that it contains I and I2 as variable, and in loop B you have I1 and I2. They are not the same, so you can add and you can subtract, but 2 is common to both of them, so I can leave 2 and tends to change one, maybe I1 or I2, I1 and I2, because we have the relationship between 3 of them here. So I can say, okay, let me change my I to I1 and I2. So if I'm doing that here, I will say that my I is equals to I2 minus I1. Then I can now change 1 to I1 and I2. So I will say 4 equals to 8 I2 minus I1 plus I2. Then I can say 4 equals to 8I2 minus 8I1 plus I2. Then I will add up the common ones. This plus this, that's 9I2 minus 8I1. Alright, now since we have this, now we can now say, okay, we have I1 and I2, I1 and I2. We can use simultaneous equation to solve them. Now let's solve them simultaneously. Now we have these two beautiful equations here. Now let's see what we can do to them in order to solve them simultaneously. I can use the elimination method by multiplying this equation 2 by 2 and multiplying this by 1. And you know, if I should multiply it by 1 and by 2, I should have the same variable. You know, elimination method depends on the same variable, so that I can all add or subtract. Okay, now if I should multiply the equation 1 by 1, I will have 9I2 minus 8I1 equals to 4, and equation 2 by 2, I will have 2I2 plus 8I1, which is equals to 6. Alright, then we can see that this and this have the same value but opposite sign. Since they have opposite side, I will add. If they have the same sign, we subtract. If I add, I will have 11I2. This and this will get rid of each other, and I will have 11I, and I will have 10 here, and I2 equals to 10, over 11, which is 0.901. Then I'm done with my I2. Now to now look for my I1. We know that this equation contains I1. I can just slot in my I2. So we will see that our I2, which is 0.901, 0.91 plus 4 times I1, giving you 3. And if you should collect the like times, that we have 4I1 to be equals to 3 minus 0.91, and you have your 4I1 to be equals to 2.09. And by the time you divide both sides by 4, you get 0.52 ampere, and that is for your I1 is 0.52 ampere. And the last one is your normal I. And remember that your I is I2 minus I1 from this equation, and you can just say that your I equals to, subtract this from this, you have 0.39, and since you have 0.39, that's your I, and then you can know the current that flows through the circuit. Now I'm not done with this question. I'm going to reverse one of the currents, and we will see what it looks like when we reverse the current. Okay, now this is the next this is the same question, but you can see that the current here, I've reversed it, like it's moving like this. Before it was moving like this. If you checked, it was moving like this into the place, but now I've reversed it. Now let's see how the solvings will look like when we start solving. Now the first rule says that we should find the direction of the current, and we know that the direction of this current is going like this one is going like this, and this one is going like this. Then we are done with that. The second one says that we should assign polarity to each resistor. This is the first resistor, is moving like this, current is moving like this. This means this is positive, this is negative. Current is moving like this, positive and negative. And don't forget, this current that moving like this is the one that's moving this way. This current moves this way also, which means it is positive and this is negative. Now this current is the one moving like this. This will be positive, this will be negative. Remember, current flows like this, positive to negative. All right, now we move to the next one, which is KJL, junction law. What does the junction law says? So if you take this, current that enters is only this I. Okay, this is our I1 and this is our I2. The current that enters this junction is only this I, and I1 leaves and I2 also leave. Let's move to the loop law. Now what is loop law? For loop A, now I'm going to move anti-clockwise in this one now. So for loop A now, I can see that it moves. If I'm starting from here, it's moved from positive to negative, and then we say that is -6. The current that flows through here is I1. We know it's current I1 that connects this wire together. If you do not get to junction, current does not split. So the same wire that is going like this is the one that is moving like this. So, and this current is I1 that we label. Therefore the current that is moving like this is I1 also. So is I. So the current that is moving here is I also. So we should note that. Now we are done with this one. Moving to the second one, it's moving from negative to positive, that is plus 10, and from here positive to negative, that's minus 2I. We know it is I also that is moving in this wire. But when we reach here, the split of current occurs, and we know that it is I2 that flows this through wire. Now we have voltage here, so we say it's moving from positive to negative, that's -6 voltage, and is moving from positive to negative, that's minus I2, because this is 1 times I2, that's I2, which is equals to 0. And by the time we resolve this, we have -6 and -2, that's -8I, and 10 minus 6, that give you +4, and I2 minus I2 equals to 0. By the time we collect like times, you have 4 equals to I2 plus 8I, and that is that for the first loop. And for the second loop now, loop B. Now this is the loop B. I'm going to move in clockwise direction. So if I'm moving in clockwise direction also, what does it look like? If I'm starting from this side, remember I'm moving this wire. Now from negative to positive of this one, that is positive, and that is I2 that's flowing through this. So I say I have I2. I'm moving from negative to positive, that's positive also, plus 6, because that is 6 voltage. And I'm moving through this, I'm moving from positive to negative, that's minus 9 voltage. I'm moving from positive to negative, that's minus 4 voltage, which is equals to minus 4, and the current that flows is I1, that's minus 4 I1, which is equals to 0. So we can now just solve this. So we have I2, 6 minus this is minus 3, and we have minus 4 I1 equals to 0. By the time we collect the like times, you can see that I2 minus 4 I1 equals to 3. Okay, this second equation, and we can see from the first equation it contains I2 and I, and second equation contains I2 and I1. Then we change one into, we will change, you have three variables like that, so you choose two variables that you choose to work with. All right, I can choose, okay, I want to work with I1 and I2. If I want to work with I1 and I2, it means you are changing I to I1 and I2. Then I'm going to change this I, and I is I1 plus I2, so I will just change that, and I will have 8 into brackets I1 plus I2, and I will have 4 equals to I2 plus 8I1 plus 8I2. And by the time I get this, I will have my 4 to be equals to 9I2 plus 8I1. So I will have this now as my second equation. Now I can now write down the equations. The first equation now is I2 2 minus 4I1 equals to 3. That's my first equation. And my second equation is 9I2 plus 8I1 equals to 4. That is my second equation. And since I have these two equations with me, the next thing I will do is that I will multiply the equation 1 by 2 so that it can change to 8, and we can be able to add them together. Okay, now we have 2 times I1, which is 2 times I2 rather, and 2 times 4, that is 8I1 equals to 6, and the second one we have 9I2 plus 8I1 equals to 4. By the time we add them together, because they are having different signs, so we have 11I2 here, and we have this, we cancel this, we have 10 here, so I2 will be equals to 10 divided by 11, which is going to be 0.91 ampere also. Now let's move on calculating I1. Now I can plug in I1 in this, since I2 minus 4I1 equals to 3, so I can just say 0.91 minus 4I1 equals to 3, and minus 4I1 equals to 3 minus 0.91. So minus 4I1 equals to 2.09. And by the time you divide both sides by minus 4, you will get minus 0.52 ampere, and that is for your I1. And for the last one, which is your I, remember your I, so we have got the second one, this is the first one. So your I is equals to I1 plus I2, and I1 is minus 0.52 and I2 is 0.91. By the time you add them together, you have 0.39 ampere, and that is that for your I. And you can see we are done. My I is still my I, my I1 is still my I1, but minus sign is there, and my I2 is still my I2. And remember, it is only I1 which reverse the direction, which means the direction of I1 is not this way, it's this way. You can see that is how you can get it, even if you don't know how to assign current. Maybe you are taking the wrong way in your current, you are still good to go, you are going to get your answer. So know that the major thing is to know that not every current cannot enter the junction, and all current cannot come out from the junction. Either two is entering, one is coming out, or one is entering, two is coming out. That is just how you assign current, and that is that about that. Now the question they can ask you again, after you've got your current and your resistance, and after you've gotten your current inside this Kirchhoff law, is that they can ask you to find the voltage dissipated by this guy, or they should say power dissipated by, they will just take any ohms resistor. Say they take 4 ohms resistor, they can just say what is the current, then the voltage dissipated by 4 ohms resistor, or they say what is the voltage that is lost, and voltage loss through 4 ohms resistor, or they say what is the power lost by through 4 ohms resistor. What you do is that what only thing you need is the current that flows through this 4 ohms resistor, and you know that it is I1 that flows through this 4 ohms resistor, and the value of I1 is clearly stated there. Then if they ask for voltage, we know that V equals to IR. Then you know that the voltage loss by this 4 ohms resistor is going to be 0.52, which is the current that flows through it times 4. So by the time you multiply, you get 2.08, and that is the voltage loss across this thing. So if you're not talking about the power dissipated by that same ohm resistor, maybe 4 ohm resistor, we are just going to use the formula P equals to I square R. And power as is like divided into like 5. We have like 5 types of power, whereby we'll be talking about power conversion, power input, power output, power dissipated from by the resistance, power dissipated by internal resistance. We have like 5 of them like that. So if you want to know more about power, maybe I will do another extra video on power and explain what they do and how it works. Now, if you are looking for the power dissipated or power lost by this voltage by this resistance, I will just plug in my value. Since the current that enters this 4 ohms resistor is 0.52, so I'm going to square that, and I'm going to multiply by the resistor. So P equals to 0.52 squared times 4, 1.08 watts. So that's the power dissipated. That's the question they ask. They will just take one resistor and they ask you what is the power that is dissipated by that resistor, or voltage that is lost by that resistor. So let's move to the second question. This is the second question. Now let's analyze this circuit. Now you can see that it has more than 2 voltage, 1 here and 1 here, and we can also see that it has more than 1 loop. So this is the first loop, the second loop, the third loop, and we want to know the number of loop. We count this also as loop, making 4 loops that this circuit has. Now let's analyze it one after the other. The first thing, to know the junction you want to take into place. Now I can take this junction to denote my current. I can take this, I can take this. If I'm to take these 2 bottom junction and I'm to locate the direction of the current, then I know that I1 flow inside, I3 flow inside this one, and I2 flow outside, because this is I2, so it flow outside and goes all around inside this one again. And likewise, this junction I5 flows out, I4 flows in to this junction, so I4 flows in, and this I3, you can see that it's flowing out, so I3 flow out. So since we have analyzed the direction of the current, the next thing is to know to polarize our resistor. Now let's polarize it. We can see that current flows in this direction. In 3 ohms resistor, currents flow in this direction, like I2 flows in this direction. So here will be positive, here will be negative, because I2 enter from this place and come out from negative side. And for 4 ohms resistor here, I1 enters from up and come out from down, which means up is positive, down is negative. For the 2 ohms resistor, I3 enter from the right and comes out from the left. So and for the last 2 ohms resistor, I4 enters from top and comes out from down. So that is how we polarize our resistor. The next thing is to use our KJL, which is our junction law, and the junction law states that the current that flow inside must be equal to the current that flows outside. Now the current that flow inside in this junction now are I2, I1 and I3. I3 and I1 enters the junction, that is equals to I2 that flows out of the junction. So that is for the first junction. For the second one, I4 flow inside. We can see I4 flowing inside the junction, so I4 flows inside, but I5 flow outside it. So I5 and I3, because this is I3, so it's the one that is flowing outside, is the one flows outside of the junction. Then we can say that we are done with the junction law. We can now move to the last step, which is our voltage law, which talks about the loop. Okay, for this one, this is the first loop. I can decide to go here like this. For the second one also, this is the first loop. I can decide to go like this, and the third one also, I can decide to go counterclockwise for everything. I can decide to just switch maybe two clockwise, one anti-clockwise, anyone I wish. Now, taking this into consideration, for the first loop, now this, let's call this loop 1, loop 2, and loop 3. For the first loop now, we are going this direction, this direction, this direction. So we say that from positive to negative of this battery, we have negative 12. From negative to positive of this resistor, we have plus, like that, because it's coming out from plus. But don't forget, it is I2 that flows through this resistor, so we say it is 3I2 because we multiply by the resistor, V equals to IR. And the third one, which is this, it goes from negative to positive, that is plus also, and it is 4 ohms resistor. But I1, this I1 is the one that flows inside the 4 ohms resistor, so it is 4I1, which is equals to 0. And analyzing this, I can say 3I2 plus 4I1 equals to 0. And that's that for the first loop. Let's now do for the second loop. For the second loop now, we can see that we are going in this direction, so I can say it goes like this, it goes like this, and it continues to move like this. Then I can then analyze it one after the other. We have from positive to negative of this 4 ohms resistor, that is negative 4, but which current flow inside it is I1 that flows inside it, so that's negative 4I. And moving from here, we have negative to positive 2 ohms resistor, that is positive 2, and which current flows inside it is I3 that flows inside it, so positive 2I3. And for this one, from negative to the positive terminal of the battery, and that is plus, and that voltage is 5, which is equals to 0. And I can just say we have minus 4I1 plus 2I3 equals to negative 5, and that is that for second loop. Let's move to the third loop. For the third loop now, we are still considering the movement like that, so it moves like this and it moves like this. We have only just 2 resistors here, so we can just, this one will be easy to resolve. So we can say that okay, it's moving from positive to negative of this battery, so I can say is negative 5 volts, and is moving from negative to positive of this 2 ohms resistor, so I will say plus 2, but the current that flows inside it is I4, so plus 2I4, which is equals to 0. And by the time we resolve this, we can say that 2I4 equals to 5, and my I4 will be equals to 5 over 2, which is equals to 2.5. Now we have even solved for 1, so remain the remaining 4 currents, because the question says we should find the currents I1, I2, I3, and I4 and I5. So let's now continue. Now we have these 2 equations left. Now these 2 equations both have I1. This is minus 4I1 and 4I1, so both of them has I1, so I can decide to leave I1, but this is having I3 and this is having I2. So what I do is that I can change either of them to I1 and I2, either of them to anyone. Now I2 is equals to this guy here, so I can just say okay, let me change my I2 to I1 and I3, so I will work with I1 and I3 like that. Now changing these to I1 and I3, we have 3 into bracket I1 plus I2, because I2 is I1 and I3, I1 plus I3 plus 4I1 equals to 0. Simplifying this, I have 3I1 plus I3 plus 4I1 equals to 0. Then adding this and this together, I have 7I1 plus 3I3 equals to 0. And Oh, sorry, this one ought to be equals to 12, so it's not equals to 0, is actually 12. So my bad. So here is equals to 12 because we transported this one to the other side. That's equals to 12. And here also we have 12, 12, and 12. All right. Now we have one of the equation now. So for the second equation, I have minus 4i1 plus 2i3 equals to negative 5. Now I can decide to multiply the first equation by 2 and the second equation by 3 such that this and this will have the same value, and um I'll be able to cancel them out. Now 2 times 7 is 14, so I have 14i1 plus 2 times 3 is 6i3 equals to 24. And for the one under, 3 times negative 4 is negative 12i1 plus 3 times 2 is 6i3 equals to 3 times 5 is 15. And this, now I will just subtract them, and if I should subtract them, 14i1 minus 12i1, I'm going to have 26i1, and 6, this will now cancel this, which is equals to 24 minus 15 will give you 39. And if I should divide this, I will have my i1 to be 39 over 26. Punching this into calculator, I will have 1.5 ampere. That is our i1. Now moving on, to get our i3 now, since we know that this equation hold for i3, I can just plug in my equation into this. So I will say that minus 4, my i1 is my 1.5 plus 2i3 equals to negative 5. You can use any of the equations that we have derived earlier. Maybe you are using this, any of them. Just prefer the one that is simpler to resolve. Multiplying this, I have minus 6 plus 2i3 equals to negative 5. And transporting this to the other side, I will have 2i3 equals to minus 5 plus 6, and I will have 2i3 to be equals to 1, and i3 to be equals to 1 over 2, which is 0.5. Then we have found my i3. Now it remains i5 and i2. Now i2 is the combination of i1 and i3. I can just add i1 together with i3. So i1 is 1.5, i3 is 0.5. Adding them together, I will have 2 ampere for my i2. Now for my i4, for my i5, it is being resolved in this equation. Since i4 equals to i5 plus i3, I can just say i5 equals to i4 minus i3, and I can say that my i5 is equals to, now i4 is 2.5 and my i3 is 0.5. 2.5 minus 0.5 is 2 ampere, and that is that for the solution. Then you are done with everything. You have seen your i1, you have seen your i2, your i3, your i4, and your i5, and then you are good to go. That is how to resolve them. But make sure you are careful, because mistakes is inevitable. Okay, this is the last question that we'll be reviewing. We can see that this type of circuit is a complex resistor network. And if you should look at this very well, we can just resolve this in parallel or in series. For instance, if I should hold on to this place, assuming I hold onto this place and I hold onto this place, then everything that will be here will be in series, and everything that will be here will be in series. Then here and here I can resolve it in parallel. But the one at the middle, will you add it to this in series or in parallel, or you add it to this in series or in parallel? That's where it becomes complex. So in this type of diagram or this type of circuit, what we do is that we find all the current that goes inside everything, and we use V equals to IR to solve this type of question. And the question they ask for this circuit is that we should look for the current that pass through each resistor, and that is what we are going to do. And we can see that current is not assigned. Now this is the direction of the current. We all know that this is from positive, current will go from positive like this, and it will distribute itself inside this circuit and will come back inside this. So we have known how it will go. Then we can now find the direction of the current. Now at this point, current will flow like this. So this one I can call it I1. The first current, I can call it I1. In this one now we know that as it reaches this junction, no any other battery source that can like give us another source. So this is the only current that is going inside this one, and this one is going to split itself by going like this and like this. And if it goes like this and like this will become I2, and this will become I3. Anyone you want to give, you can give this I2, you can give this I3, it doesn't matter. And as this one is going like this, as it reaches this junction, it also splits, because this is the junction, so it moves like this, it moves like this also. So I can call this one I4 and call this one I5. You can see how it goes like that, and it comes like it comes here. For this one comes here, which means this I4 also will come and contribute to I2. Then at this point we have I6 like that, because this I5, so I6 will move like this. Since this one move like this one move like this, so this one will come out of the junction, and that's I6. And at this place now, at this last junction, this is I6 moving to the junction, I5 moving to the junction, and I1 also. You can see I1 is the one coming out. So I1 is the one that goes like this, that reaches there. You can see that now the question is to find all these I1, I2, I3, I4. It is not hard. The next thing on our steps is to find the polarity of the resistor. Now current flows from here to this place, then here should be the positive side of this battery, and here is the negative side of this battery, of this resistor. And for this one also, current enters like this, so here is the positive side and here is the negative side. And for this one, current enters like this is the positive side, this is the negative side. For this I6, this is the positive side, this is the negative side. For this one, this is the positive side, this is the negative side. After doing that, then we can now move to our KJL, which is our junction law. Now for the junction law, at junction C, which is the one at top, so at junction C, what's happened there? I1 is the only one that enter, I2 and I3 comes out. So I can say I1 is equals to I2 plus I3. That is for junction C. Now for junction A, what can we see? For junction A, we can see that I1 enter, I4 enter, and I6 come out. So I can say that I2 plus I4, because both of them enters, and I6 comes out from that junction. And for junction B, what can we see? We can see that I3 enter, I4 comes out, and I5 comes out. So I can say I3 equals to I4 plus I5. And for the last junction, which is junction D, which is this, we can see I6 enter, I5 enter, and I1 come out. And I can say I1 equals to I5 plus I6. All right, now since we are done with our KJL, then we move to our KVL. Our KVL now, since they have given us the direction at which we should move, it doesn't matter, we can choose to move in opposite direction. It is our choice, it's not their choice, it's our choice to choose. And then we can just put it there. But since the direction is there already, we don't need to stress ourselves. So going like this of this circuit, we go inside from positive to negative. Since we are coming out from negative, so we have minus 1 is the ohms resistor and is multiplying I2, which means 1 times I2 give you I2. So that is I2 resistor voltage in this place. And moving like this also, we have another resistor which moves from positive to negative, and that is the negative I6 also, because I6 times 1 is still I6. Moving like this is moving from negative of this battery to the positive of the battery, that is plus 13, giving you 0. If we should analyze this, so we have I2 taking everything to the other side plus I6 equals to 13. So this is one of the equations that I have. Then I move to the second loop. So if this is loop A, this is the voltage in loop A. So if this is loop B, so voltage in loop B, now let's check. Now it moves like this also according to how it was being given. So I move from positive of this I2 and 1 ohms resistor into negative, that's negative I2 also, because that is I2 current that is flowing through this resistor. And I move like this from negative to positive of this 1. So positive is where I come out from. That's plus I4, because I4 times 1. I4 is the one that I move inside it. I4 times 1 is I4. I'm moving like this also. Minus to plus, that is plus. So plus I3, because it is 1 ohms resistor also, which will give you 0. And if you should analyze this also, I can say I2 equals to I4 plus I3. That is my second equation. And the last one, which is the loop C. Now for loop C now, I can see that they are moving this way. So from negative to positive of this battery, that is I6 times 1, that is positive I6. And I'm moving from negative to positive of this battery, that is positive also, that's positive I4. And then from positive to negative of this battery, so I have minus 2i5. You can see 2 is the ohms resistor that is here. 2 times i5 is 2i5 equals to 0. And analyzing this also, I can say that 2i5 is equals to i6 plus i4, and I'm done about the third loop like that. So I have 3 equations there, but this is the question. I have 6 currents that I am going to find: i1, i2, i3, i4, i5 and i6. So how can I find it? Since from your from your loop law, you have only just 3 equations, what you just do is that you reduce all these 6 currents into just 3, because you have 3 equations. And we all know that in simultaneous equation, if you are looking for 3 variables, you must have 3 equations. If you are looking for 2 variables, you must have 2 equations. Then it be here that we are given 3 equations, probably we should use 3 variables such that it will be easy for us to find. In our last example that we use, we can see that we have 3 junction, also 3 loops also, but one of the equations has even given us the answer. That's why we are using only 2 in the last one. But here we have 3 equations, and we must have 3 unknown. And inside our 3 equation, we can see that we have various unknown in it, because there is I2, there is I6, there is I4, I3 and I5 there. Then what should we do? From this one, we can see that our I1 has been settled, because I1 is equals to I2 plus I3. Then I can now choose which current I wish to work with. I can choose I2, I3 and I4. All right, choosing I2, I3, I4, I can now, you can choose any of the current that you want to work with. You can choose I3, I4, I5. You can choose I4, I5, I6. You can choose I1, I2, I3. But make sure you go for the convenient one. And the one I see that it can be convenient for me here is I2 and I3 and I4, because I2 and I3 has been expressed by I1 here. So I can see that I2 and I3 is easy for me, but I can just choose any one of it and add it to it, which is I4, with my own opinion. Now, since I have known that, then I'm going to find my I1, because since I'm working with this thing, I'm going to express I1, I5, I6, which are not known, which are the next unknown. I'm going to express them in these 3 form. But I1 has been solved, which is I1 plus I2 plus I3, which is our I1. So this one has been solved. Let's check I5. Now, how can I resolve I5 in I3 and I4? Coming back to this equation, I have I5 here, I have I5 here. You can see this one has 3 and 4. So I can just say that from this place, my I5 is equals to I3 minus I4. I can represent it as 3 and 4, which is right here. So I can just say my I5 is I3 minus I4, and down, that is for I5. Then moving to I6 now. I have I6 here, I have I6 here, and I want to express it in 2, 3 and 4. Here this one has 1 and 5, this one has 2 and 4. Then I can just choose this, that my I6 equals to I2 plus I4. Then I'm done. Since I can analyze everything with the 3 one that I want to work with, and we can see I have analyzed the remaining unknown like this, then I can now come back to my equations, my first, second and third equation. Now coming to my equations, now I will, wherever I see I6, I will just plug in this. Wherever I see I5, I will just plug in this. Wherever I see I1, I will just plug in this, such that when I resolve everything will later end up in I2, I3 and I4. Then let's move. From this equation 1, I see I have I2 plus my I6 is now I2 plus I4. I will just represent that with this, and I will move on to equals to 13. I2 plus I2 is I2 plus I4 equals to 13. Then I have new equation, say equation 4. Now moving to the second one here, we have I2, I3 and I4 already, so we don't need to rewrite anything. So I can just say my I2 minus I4 equals to I3, so that I2 and I4 will be on the same side. It's nothing but it's just the same thing. Now moving to, say this one is equation 5, moving to the next one, which is this last one. Wherever I say I5, I put this, and I see I6, I put this. So I5 is 2 into bracket, I5 is I3 minus I4 equals to I6 is I2 plus I4, which is equal plus I4 again. Then I can now open the bracket and simplify. This is 2I3 minus 2I4 equals to I2 plus 2I4. If I should collect the like terms, I can have 2I3 equals to I2 plus 2I4 plus 2I4, and this can be added. So I can say my I2 plus 4I4 is equals to 2I3. Then I'm done with that. Since I can represent each equation like this, and I can see my equation 4 as 2 and 4, and equation 5 as 2, 4 and 3, and my equation 6 as 2, 4 and 3, then I can now choose what to work with. Then I can say that I can use substitution method, in which I can say I plug in my I5 into these 4 and 5. If you have calculator, you can just punch it inside calculator and get your answer straight away. Now since I have I4, I5 and I6, and they are all of 3 variables I want to work with, and I can just say that equation 5 and equation 6 are having I3, but equation 4 is not having I3. What I will just do is that I will put I2 minus I4 in place of I3 in equation 6. So I will say that put 5 in equation 6 please equation 5 in equation 6. Then I will have I2 plus 4I4, which is equals to 2 into bracket. My I3 is I2 minus I4, and solving this I have I2 plus 4I4, which is equals to 2I2 minus 2I4. Now resolving this, carrying I2 to the other side and carrying 2I4 to the other side, I will have 4I4 plus 2I4, which is equals to 2I3 minus 2I2 minus I2, and then I can say that this give me 6I4, which is equals to I2. Since I have related I2 and I4 together, I can now put it inside equation 4, because equation 4 has I2 and I4. Then I say put I2 in equation 4, and equation 4 is 2. My I2 is now 6I4, which is plus I4, which is equals to 13. 2 times 6, that is 12I4 plus I4 equals to 13. 12 plus 1 gives you 13I4, which is equals to 13, and you can see that I4 equals to 1 ampere. Since I have obtained my I4, then I can plug it back inside this one, because my I2 depends on I4. So my I2 will be 6 times 1, which is 6 ampere also. Then I have obtained my I2. Then I can now move on in solving for others. Now others is I3, because I3 is related to I2 and I4. I can say I3 is equals to I2 is 6 and I4 is 1. So I can say my I3 is equals to 5 ampere. Since I have obtained that, I can now come back. I have seen my 3 variables. I can now go back to this to look for the other variables. Now for I1, which is equals to I2 plus I3, my I2 is 6, my I3 is 5, then my I1 is 11 ampere. That is for I1. Then for I5 now, which is equals to I3 plus I4, my I3 is 5 and my I4 I3 minus I4. My I4 is 1. Then I say my I5 is equals to 4 ampere also. Then lastly remain my I6. My I6 is related like this: I2 plus I4. My I2 is 6 and my I4 is 1. Then my I6 is 7 ampere. Since I have analyzed that, then I can now say that I have seen the current that flows into each resistor, because I have seen I1, I have seen I2, I have seen I3, I've seen I4, I5 and I6. Then I can now move to the next question, which says we should find the total resistance, and that is all for today. Now to find the total resistance, we know that total voltage is equals to total current times total resistance. If you want to look for the total resistance in this circuit, now total voltage is 13, is the one that is being distributed to everything, and total current is 11, because we can see that it is I1 that enters here. So I1 is the one that leaves, that distributed itself all into them, and my I1 is 11 ampere. So my I1 is 11 and my R total is what I'm looking for. So R total is now equals to 13 divided by 11. By the time you use calculator to solve this, you get 1.18 ohms, and that is that for the total resistance. That is that for today's video. Please like, comment and subscribe. Thank you very much.